Good day, everyone. This is still Module 7A on pointers, or we're focused now on our dynamic memory allocation. We'll start with the definition of the size of keyword, which will be used in various dynamic memory management functions, to be followed by using of dynamic memory allocation for variable length arrays, and the application of this memory allocation for dynamic 2D arrays. Okay, let's now start with the definition of the size of keyword. Okay, this is a special unary operator, meaning isa lang yung operand niya. Okay, it is used to determine the size, okay, kung ilang bytes yung meron sa isang data type. Okay, ito yung example. As you can see here, different use of size of. Okay, yung dalawa yung gamit dito. Yung una, size of variables. Okay, C, S, ito yung mga nasa left side. C, S, L, 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 I, F, L, D, and D. Bibigyan sa'yo yung size ng mga variables na yan. Okay, depende kung ano yung nakastore sa kanila or anong type of data yung na declare for them. Right? If yung size of natin is ginamit sa array, bibigyan sa'yo is yung total size in bytes of all the elements na nasa array. And kapag sa pointer naman, bibigyan sa'yo yung size ng variable na pinopoint ng pointer na yun. Okay? Second use niya is itong nasa right size. So, size of ng data type talaga. So, explicitly niya sinasabi rito yung sinusulat dito size of the character, char, size of short integer, size of int, long, 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 float, double, and long double. Okay? Let's look at the result. The output of this code. So, as you can see here, size of C or yung character, size of char is 1. For the short, you have 2. For integer, for the variable I, which is an integer, parehong 4 yung size nila. In bytes lahat yan. For the long, we get 4. For the long, we get 8. For the floating point type, we get 4 bytes. So double 8. Sa long double, pinakamarami, 12 bytes. Okay, as you can see, yung size of ng array dito, since your array is made up of 20 integer elements, multiply mo lang by 4, tig-isa yun. So 20 times 4, it's 80. Kaya 80 ito. Okay, yung pointer natin points to the array. So bakit 4 po ito? Kasi, di ba, if you recall, ang pointer natin, nakapoint lang sa first element. Okay, so start ng first element ng array. Ano ba yung first element ng array? It's an integer. So isang element lang yun. Ang size ng isang integer is 4. That's why 4 yung output dito. Yung sa size ng pointer. Right? So that's how we use yung size of na function or operator rather. Okay? So, gagamitin natin yan sa mga dynamic memory allocation functions. Pero na ba yung dynamic memory allocation? It's actually used kapag arrays yung pinag-uusapan. If yung array size natin hindi natin alam, or malalaman lang natin during execution, so dalawang cases, either yung array size natin is a user input or kinakalculate after many computations sa ating execution ng code. So, ang ginagawa natin is we apply this dynamic memory allocation, or yung isa is yung na-apply natin sa previous modules na variable length arrays. Okay, sa 1D array natin. So, magiging focus lang natin is itong number 1, dynamic memory allocation. Ano ba ginagawa sa dynamic memory allocation? Basically, nag-obtain tayo ng mas maraming memory space during execution, or nag-release tayo ng memory space during execution kapag hindi na kailangan. So, mas flexible tayo and mas efficient yung paggamit ng memory, kasi kapag kulang, nagdadagdag siya. Pag sobra, pwede nating bawasan. Okay? Magagawa mo lang itong dynamic memory allocation if we use the library function or header file na stdlib.h. So, just include that sa hashtag include directives natin sa start ng ating code. We have 4 here na i-discuss. Dynamic memory allocation functions or memory management functions. We have malloc, calloc, realloc, and free. Sige, start tayo sa malloc. With malloc, memory allocation, malloc, memory allocation, malloc. Okay, ang ginagawa nito, nag-reserve siya ng memory space of a specified size, okay, certain size, tapos i-return niya pointer. Yung pointer na yun magpo-point sa first byte ng allocated space natin. Okay, Ang syntax is ganito. Since pointer nga yung ina-output or nire-return ng ating malloc, syempre i-assign mo siya sa isang pointer. Let's say dito ptr name. Okay, sa isahin natin that ptr name is the name of our pointer na paglalagyan ng i-return ni malloc. Okay, it's actually of type kung anong ilalagay mo rito sa cast type. Pero by default, yung output or i-return ng malloc function natin is void function. Nilalagyan lang natin ng cast type if wanna transform or change yung void natin into a certain data type. Okay, so that's our cast type. Next byte size is the size ng memory na gusto mong i-allocate. Okay, dyan natin ginagamit yung size of operator na na-discuss sa previous slides. Okay, and finally, or the most important here is kapag gumagamit tayo ng malloc, hindi siya nag-initialize ng memory. Meaning, hindi niya nilalagyan niya ng initial value. Kung ano lang yung original or existing na laman ng kinuha mong memory space, yun na mismo yung i-allocate niya space. So, possible na may laman siyang trash or garbage value. Okay, the second function is calloc or your contiguous allocation, alloc. Okay, ang ginagawa niya, it allocates multiple blocks of memory space. Yung malloc kasi isang tuloy-tuloy lang kung ano yung size na binigay mo, yun na yun. Okay, dito, pwede niyang i-subdivide. So, you have multiple blocks na may same sizes. Ito yung syntax niya. Similar sa malloc, pointer name, and then your optional cast type, calloc, and then may n na dito kasi you're creating or you're allocating n memory blocks na may same size na ito. So, individual size itong byte size na ito. Okay, and ang difference niya then sa malloc is it initializes your all bytes of memory to 0. So, useful ito sa pag-allocate ng memory for arrays. Bakit? Kasi i-initialize niya lahat ng elements ng array mo to 0. Okay, so that's your calloc function. The third important function would be the realloc function. So from the name itself, it reallocates a memory space, meaning pwede niyang one is pwede niyang dagdagan yung memory space, extend, and two, pwede niyang bawasan. Okay, pero ang maganda rito, hindi niya babaguhin. Okay? Yung original na laman na nung existing memory space. Syntax niya ganito, ptr name. Okay. Actually, hindi lang nilagay pero may andyan pa rin yung cast type na optional asterisk. Okay, realloc ptr name. Okay. So, important lang na is ilagay dito yung name ng pointer na gusto mong i-reallocate. Pero same lang naman to usually kasi pinapalaki mo lang or pinapaliit lang. Okay, itong new byte size is either larger or smaller than the previous size no memory na inallocate natin sa ating pointer. Okay, so sabi ko nga, yung new size na yan can be larger or smaller than the previous memory. And yung location ng newly allocated block is not necessarily same sa previous memory block. Kasi ang ginagawa ng realloc is it creates a copy of all the previous data tapos nilipat niya sa new location na mas marami na yung memory space. Okay, so hindi talaga kaya nililive niya lang yung content as it is. So okay na okay to if, for example, you want or you initially allocated 50 elements okay, para sa isang array pero during execution kailangan mo pala 100 elements. So pwede mong gamitin yung realloc para palakihin yung allocation ng memory for that array. Okay? On the other hand, kapag kunyari 50 ngayong inallocate mo pero 10 lang talaga kailangan mo, pwede mong gamitin yung realloc to reallocate to a smaller memory para mas ma-free or hindi na magamit yung hindi kailangan na memory. Okay, so this is very useful. Kaya nga siya tinawag na dynamic memory allocation kasi flexible siya. Okay? And itong tatlong to, malloc, calloc, realloc, they are actually returning a void pointer by default. And yung typecasting na yan, hindi naman required if hindi naman natin gagamitin yung values nung memory, nung array natin. Okay? Ginagamit lang naman natin siya sa allocate ng memory lang talaga. So yung dereferencing and yung cast type na ito, is not required. Okay, and then, yung function natin, mag-return ng null pointer if yung memory natin is not sufficient. Pero most of the time naman sa modern computer, kaya naman na yung memory na yan. Last would be the free function. Ang ginagawa naman ito, nagre-release or nagde-deallocate ng memory. Okay, so sa dynamic memory allocation, it's very advised to explicitly deallocate yung previously na allocate mo memory. Kasi nga, one of our most important reason kung ba't gumagamit ng dynamic memory allocation is to conserve, number one, conserve energy, and number two, efficiently use, sorry, hindi energy, memory, okay, or efficiently use yung ating memory. Okay, so kung hindi naman na kailangan, let's just layain na natin yung allocated memory for them. Okay. Let's see example 7a-8. This one is a sample code which demonstrate yung paggamit or application ng dynamic memory allocation functions sa Sentinel controlled program. If you recall, ang Sentinel controlled program is user-defined yung input, tapos titigil lang yung pag-scan niya once it encounters a sentinel or a certain value na magpapastop yun sa pag-scan ng ating program. Okay, let's show this one example. As you can see here, nag-declare siya ng pointer with a name grade array. Succeedingly, nag-declare siya ng integers n and index with initial values 1 and 0 respectively. Okay, and you can see here yung paggamit ng calloc. Okay, as you can see, nag-typecast siya. So, integer yung gusto niya pointer for the na ilalabas ng ating calloc or i-output ng ating calloc. Pero hindi na yan kailangan kasi you can always assign any type of integer, any type of data or any type of pointer to a void pointer. Or pwede rin, di ba, by default ang nilalabas or nireturn ng calloc is a void, tapos ilalagay mo siya sa integer na pointer, that's also valid pa rin. So, typecasting is really optional. As you can see here, n blocks, di ba, initial is 1. So, 1 block of array of memory lang with size of integer. So, 4 bytes lang. So, initial lang naman yan para lang may paglagyan yung initial value ng i-enter ni user. Okay? So, yung grade array na yan has one element is initialized din sa 0 kasi nga gumamit tayo ng calloc. Okay, you can also use this, yung int malloc naman, pero as you can see explicitly niya, minumultiply si n dun sa size of int. Okay? So, unlike dito kay calloc na nakahiwalay. Pero yun, ang ano dito, hindi niya kapag gumamit tayo ng malloc, hindi niya i-initialize to 0 yung laman ng grade array natin. Okay, next. Enter a negative number to end, just to note yung sentinel natin. So, ang sentinel natin sa code na to is a negative number. Pag-print sa screen, next is grade array. Okay, basically, magpapahingi tayo ng input from the user. Okay, starting from n-1, diba? Grade array 0. So, yung index ng first element natin, diba? Grade array 0. Or 1 minus 1. Okay, sa scan ni user and then sa store niya ka grade array 0. Okay, if you recall this, ito yung ating offset notation for a pointer, diba? Kapag yung ina-add natin, okay, sa pointer math, kapag we add an integer to a pointer, ang i-move niya is yung location or yung ipo-point niya. So, this time, papoint na to sa next element ng ating grade array na array. Pero if hindi kayo sanay dyan, you can also use this index notation for our pointer. Pero as you can see, di ba hindi naman array yung pagkaka-declare dito. It's a pointer itself. Pero pwede naman tayong gumamit ng index notation as what we have discussed sa previous content. Okay, and as you can see here, gumamit siya ng while loop, okay, habang yung input user is hindi negative or greater than or equal to 0, it will keep on increasing the value of n or yung size ng ating grade array. Okay. Okay, and then yung magre-reallocate siya, di ba? Reallocate yung memory. So kung papalaki ng papalaki yung n, yung size natin, papalaki ng papalaki rin itong i-allocate na memory or reallocate na memory. So ito yung syntax nun, yung name ng pointer natin na gustong i-reallocate, na pointer to the memory na gusto nating i-reallocate. And then, ito may enter pa rin time size of ng integer natin. So habang hindi nag-input si user ng negative value, it will just keep on reallocating, okay, increasing the size of our grade array and then reallocate na reallocate. Tigil lang siya once i-input ni user is a negative number. Okay, nagpe-print niya rito. Enter. User has entered these number of elements. Okay. Now, for itong part na to naman, pe-print niya lang yung grade array natin. Ito, ginamit niya naman na ngayon is the index notation for our pointer. So, pwede rin yan. Pero, syempre, pwede rin naman itong ganito. Asterisk grade array plus I. So, this one is your offset notation din. So, either way, that should also work. Okay? Dito may n-1 kasi nga, yung last nating input is hindi ka talaga kasali kasi nga that's a negative number. Okay? Sige, next. After ma-print lahat ng elements ng grade array natin, i-free niya na yung memory allocated for it. Alright? So that's dynamic memory allocation. Let's try running this code, F9. Enter a negative number to end. Okay, isa-isayin natin. Say 87, 91, 92, 94, 88, 90, 96, 92, 99, 76. Kunyari, wala na. So, negative number. So, let's say, negative 1. Dapat magtigil na yung pagkuha niya ng inputs. So, as you can see here, nag-enter yung user ng 8 elements and they are as follows. Diba? So, this code worked well. And that's an example of the use of our dynamic memory allocation pagdating sa 1D array. Sa ating next content, I'll be discussing how to use these dynamic memory allocation functions for 2D arrays. Okay, so for now, thank you for listening.